So it's a Leetcode 79 problem. It's a medium problem. So it states that we have given an m cross n grid of characters board and a string word. Return true if word exists in the grid. Okay. So yeah, so we are given with a board a b c e s f c s a d e e, and we have this word a b c c e d. Okay, I will make it simpler. I will take some other example. Okay, I will take let's say a b c d e f. Okay, now our word is a b e. This is our word. This is our board. Okay, so yeah, so we need to check if ABE is present in this board. Okay, so what's the condition of like comparing with this word, this 1D array to a 2D matrix? Okay, so so how we will do, what's the rule? The word can be constructed from the letters of sequentially adjacent cell. Okay, so if a cell is, if we are at any cell, so the adjacent cell means it's vertically up and down or horizontally right and left. Okay. Yeah, so vertically and horizontally neighboring. Okay, then we can construct word. Okay. Okay, so yeah, so what it means, let's say we are at we are at B. Okay, if we are at B. Okay, sorry, at B, then where we can go, we can go to BA, we can go to BC, we can go to BE. Okay, so yeah, so likewise we can sequence now from BE, where we can go, we can go to BEF. Okay, so now likewise we can move vertically up and down, horizontally right and left. Okay, and we can construct word, and if our temporary or current word matches the word given, then we will say we will return true, or otherwise we will return false. So this is a problem statement. Okay, so now let's talk about so let's talk about intuition. What's the intuition here? Okay. So for solving this problem, if you need to construct a word, okay, you need some starting index. Okay, so this is a like 2D array. It's a 0 0 0 1 0 2 1 0 1 1 1 2. Okay, the coordinates of this 2D array. Okay, now what you will do, you need to have a starting point from where you can start constructing the word. Okay, so let's say you are at 0 0. Okay, you are at 0 0. Now what you will check, you will check, yeah, at 0 0 we have a character. Okay, yeah, so our first character is matching with a, yeah, it is matching with a. Okay, so now we will take it in consideration. We will move to right. Okay, we will move to the left also, we will move to the vertically up also, we will move to the down also. Okay, so we are at A, where we will move, we will move to -1, 0, we will move to 1, 0, we will move to 0, 1, we will move to 0, -1. Okay, so we have all these options. Okay, so here we have crossed the edge of the board. Okay, -1 is like imaginary index, so yeah, we will not consider this. Okay, for 1, 0, so 1, 0 is D. Okay, so we will consider this. From A we will move to D, then it's a AD. Now at this point we will check, first we will check whether D is matching with B. Okay, so our current word is A. Okay, now it's have length 1. Okay, so we will check the second letter which is present in the word. Is it matching with the current word, current character at the board? Okay, so is D matching with the B? No, D is not matching with D, so we will not consider this. Okay, okay, now this will return Here also we will return false. Okay, this it means what it means. We have started with a, we haven't reached any index where we have found this word. Okay, so this is not our answer. Okay, so we have moved to 1 comma 0 ad. This is also our not right answer. Okay, so here also we will return false only. Okay, this path fails. Okay, now what we will do? So when this path will fail, okay, first we have gone to this path fails, we have gone to this. Here we didn't have index. Okay, now we will move to this path. Okay, now this path will fail, we will go back to a. Now we will try exploring other part. Okay, okay, so what we will do, we will go to 0 1. 0 1 is b. Okay, now first we will check b is matching with this current this letter. Yeah, b is matching, so we will include this. Okay, so yeah, now we will go deeper into this. If ab is matching, then we will, now our index is 0 1, and okay, now we will, what we will do, now we will search this e. Okay, now we will search e with the starting index 0 comma 1. Okay, now our word is e itself. Okay, and our starting index is 0 0, and what now and our matrix will be this DEFC. Okay, so as you can see, okay, you are breaking your problems, okay, into the small problems. And how? First you have taken a. Okay, when a matched, then you search for b in this matrix. When you have matched with b, okay, then you have search for e in this matrix. Okay, so yeah, likewise you are breaking your problems into the smaller problems, and if a smaller problem gets solved, then a bigger problem will get solved. So here, from here you can see that it's a recursion. Okay, because recursion means breaking of a problem. Okay, now here one more concept we need to have. Okay, let's check. Yeah, 0 0 0 0 0 0. This is a visited array. I have used visited array concept in previous videos also, but here I will explain more. Okay, so now because here we will need this. Okay, so why we will need this, we will check. Okay, let's say you have a word abe, and the first letter match with the starting index 0 comma 0. Okay, if it wouldn't have matched with the 0 0, you would have searched along the complete matrix where it would have matched. That would be your starting index. You get this point? Okay, let's say instead of your a being here, if your a be, let's say if your a is present here, then you will search first the entire matrix. You found that yeah, this a it is matching with the first letter of a, then yeah, you will start from here. Then it would, okay, similarly you will like search for the complete matrix, and you will check where your first letter is present. Okay, from there you will start. You will go to the recursion. Okay, you will break into the small problems, you will solve this problem. Okay, let's move it to f. Now, so the problem is in this. Okay, when you are doing recursion, okay, let make it a little bigger. A B C D E F. Okay, you are at index 0 0, which is a. Okay, now you have chosen. Okay, so I will like write dfs, let's say help is your function. Okay, you are at like 0 comma 0. Okay, and your current word is a. Okay, you have matched. Now you will go to this path. Okay, as I have explained, you will go to this part, you will go to this part, you will go to, okay. I'm explaining us this case here, okay. You will go to 1 comma 0, here you will go to AD, okay. And yeah, this is not your answer. Now what you will do, okay. So when you have like considered A, okay, first of all we need to mark it as a visited, okay. So our currently A is not visited, okay, we have visited A, so we will mark this visited of 0 comma 0 true, okay. What we'll do, we will mark it as visited, okay, it is visited now. Why we will mark it visited? Because once we go back to other part, okay, then when we come, then let's say, okay, why we will mark visited, I have gone to B, okay, from B if I would go back to A, then it would be a loop, okay. I don't want to make a loop here, okay. For that I am marking it visited. This is simply clear, okay. So what I will do, when I will move to index T, okay, I will mark A visited. I have considered D is not equal to B, okay. The word was AB, okay. D is not equal to B, okay. So I will not consider this. I will neither mark D as visited, okay. Now this is not my answer. But what's the problem here? Let's say I just go back, okay, and I didn't mark A unvisited, okay. From here, okay, I will return false. This is not my answer, okay. And I go to this, okay. So what happened? A is visited, and if A is visited, then it will not go to B, which is a correct path. This is a correct path. So this is a correct path, A, B, E, but I have visited D before and I have marked A as visited, and this part didn't return me the correct answer, okay, because DFS will first explore this part no matter how many words are there, C, F, okay. But this DFS will explore this part and this will say that it is like this path is not correct, and from we can check A, then when we will get back here, then A would be visited. Now if A would be visited, then we will not explore other part because A is visited, okay. So before moving to the back we need to mark A unvisited, okay. So here what we will do, we will mark A unvisited, we will turn it to 0 again. Now then we will go back to A. Our answer is A only. Now A is unvisited, so we can explore other paths, okay. So what this is called, backtracking. Okay, backtracking simply means, okay, you try a path, okay, that path fails, you undo that path. You undo means you mark it unvisited or something, you undo that path and you try another path, okay. So backtracking is a strategy, while recursion, backtracking will always use recursion, okay. Okay, so recursion is a concept of tracking. So many people get confused in recursion and backtracking, so I have like explained it a little more here. Recursion is breaking a bigger problem, into a smaller problem, okay. So this is kind of a chart, okay. Backtracking is a strategy to solve a problem using recursion, and recursion is itself like breaking a problem into a smaller problem, okay. So here this is a recursion, okay, we are calling all the four sides, okay. But when we are doing A unvisited, when we are moving back, okay, that thing is called backtracking, okay. And yeah, it will always use recursion. So I think we are clear with concept, we are clear with intuition, okay. Let's check for the base case, okay. I think you all good, you all would have got the idea just of the problem and how we will solve it. So we will we will go through the all the elements of the matrix. We will check if it is matching with word the word which is present. We will consider it in our answer. Okay, then we will explore that part using help of TFS. If it matched, then we will return true. If it didn't match, we will backtrack with that part and we will explore another part. Okay, good. So yeah, how base case will look. First of all, let's say what our recursion needs. Okay, we have board. Okay, this is a matrix. We have word. Right now we have two things. Okay, first of all, we need starting index. Okay, I comma j. It can be 0 comma 0. It can be any index in that matrix. Okay, we need current word. Okay, we need current word. Okay, instead of current word, for optimization some people take length of that current word. Okay, I will tell you why, but here we are taking current word. Okay, now we can take k as self, and what else we need visited. Okay, yeah. So what this function will do, what we are expecting, here. Okay, so if I am at I comma j. Okay, and I already have matched k characters. Okay, so what's my expectation is, my expectation, can this function helps me to, can this function help me to match the rest of remaining words. Okay, the remaining character which is present in word. Okay, can this function help me? Yeah, so this function helped me, and that's why it calls recursion. Okay, now so we are standing at I comma j. We are exploring, we are digging this part, we are deep diving into this part. Okay, so base k, first of all, that I comma j. Okay, I should not be less than 0, or I should not be greater than. Okay, so yeah, it's a boolean. Like, this function is not void, this is a bool. It will return either true or false. This can be void also, you can have a global answer also. Okay, this is up to your choice. Board dot size. Okay, or j should not be less than 0, or if j greater than board of 0 dot size. Okay, in all, yeah, in all this case we will return false. Okay, now second case. Now the second case. Okay, so let's say if you consider current, or if you consider k, I am considering k here. Okay, so if k equal to word dot size, it means that here in ABE, when I was at A, my k is 1. When I have gone to B, my k is 2. When I am going to E, my k is 3. Okay, when k is 3, k equal to word dot size, it means I have matched my complete word. Okay, and yeah, it is matching, so I will return true in this case. So yeah, if k is equal to return size. Okay, sorry, return true here. Now what's the base case? I'm erasing this. k equal to outside, return true. Okay, now this, what if my, yeah, if I comma j is visited already, as I have said, if it is visited, we don't, then we will return false. We don't need to go to that path again. Okay, if we have to go to that path, we will mark it as unvisited, then we will go to that path. Okay. Okay, now what, one more condition, what I was doing when I was going down any path. Okay, when I was going down any path, then I was matching D with the B. Okay, so how I will get this position? With the help of K. Okay, now I will match with D and B. If it is not matching, then I don't need to compare. It is it is worthless comparing. If D is not matching, of course the word will not match. Okay, so what here, if word of, okay, K is not equal to what, board of ij. Okay, then what we will do, we will here return false. Okay, so yeah, these three are my base cases. Okay, visited 4, sorry, this is like edge case, this is like if k equal to, then in this case only we will like return true, and if visited of ij equal to, it is already visited, then we will return false. If word of k is not equal to word of ij, yeah, then we will return false. Okay, so yeah, this is base case. Now let's solve the problem. Okay, so we will have our main function. What's happening? We will have our main function. Okay, yeah, so exist, yeah, the function name is exist. Okay, vector of character, board and word. Okay, word is string. This is given, so I'm like doing the pseudo code here. Okay, so my writing is bad. What we will do here, we have board. Okay, so first of all we will iterate over board, okay, size j plus plus. Okay, now what we'll do here, okay, so first condition, if our board of I j equal to word of 0. Okay, if our first correction matches, then only we need to go inside, otherwise it doesn't make sense. Okay, and after it what we can do, we can have a function help, okay, which have board, okay, I comma j is our starting point. Okay, we will take current or k. Let's take k. K is our the character which is matching. Here we can have it as 1, or let's say pass it as 0. Okay. What I have taken in this example, k or v. I have taken k. Yeah. So yeah, let's take it as 0. And then we need to take visited. Okay, so we have to define visited also here. Vector of int, just expand this, visited of n vi of m comma 0. Okay, this is like we will define visited array for every time. Then we will do the DFS, and yeah, if let's say this is a bool, f equal to this, if this is true, if this help returns true, then we will return true. Okay, otherwise in the end, after both loop, we will return false. Okay, so like this is the main, like the main function which we will have. Okay, I will explain with the code here later now. Okay, so yeah, this is a function bool exist. What we are doing, we are taking the board size n and m. Okay, for we are traversing through the loop. Okay, if board of ij equal to word of 0, it means that we are matching the first character. Okay, if I told you if the first character matches with the word, then yeah, then only we need to explore that part, otherwise we don't need to explore that part. Okay, then what we are doing, we are making visited every time. Why we are making visited every time? Because otherwise what you will have to do, let's say you have declared this visited here. Okay, then what you need to do, you need to unvisit every, when you return from this DFS, then you need to unvisit the whole visited array. So, okay, so better than like make a new visited array here always every time. Okay, so this is our DFS or recursion. What it have, it have board word I comma j, this is k. Okay, if first character matches, then k is 0 and we are passing visited. Okay, and if it is true, if this DFS returns true, then yeah, then our word exists in this matrix and we will return true, otherwise it will return false. Okay, so what we are doing, yeah, we are going to the A with B, C. If the first character matches, then we are exploring this part. Okay, okay, now let's say how we are exploring this part. I have already written the base case. Okay, so this is our base case. Okay, sorry. So yeah, if k equal to word size, this was our base case. This was also our base case boundary check. Okay, I have included this visited and board of that. Okay, so yeah, it was first, it is first, third, fourth. Okay, you can check all our four base cases are present here. Now what we will do, when we have set for the base cases, okay, let's say our first word matches with the current position. Okay, then we will mark that as visited. Okay, what I have said here, when we are moving to D, we will mark A as visited. Okay, so yeah, same thing. Now what we will do, like we will go to vertically downward, vertically upward. Okay, and f is like found variable. This function returning bool. Okay, so every part will return true or false. When it will return false, when it fails in this check, or when it fails in this check, 1 3 4 condition will return false. Okay, or if k equal to word outside, then it will return true. Okay, so either this function will return true, either this function will return false. I don't know. I will just increase my k plus 1 because I have checked here that yeah, board of ij is matching with the word of k. Yeah, then okay, I am fine, I can add it to my word, current word. Okay, when I have checked all this, I will backtrack that path with which I have told you why we will do this, and we will return this found. Okay, okay, in the end it will return whether my word exists in the matrix or not. And if this function is true, if we have started from any coordinate and we have got the k equal to words dot site, then yeah, that part will return true. And if we will check, yeah, that if it is returning true, we will return true. Okay, now we will say that the function will, that word is existing in this, otherwise we will return false. Okay, so yeah, so I think we have covered all thing: intuition, backtracking, base cases for this problem code. Yeah, yeah, yeah. So let's wrap this up. Let's meet into another video.